how do I represent what postulate 1,6 is saying? Just by looking at that ABC point on that line. You got it or no?
Yeah.
Oh.
Then tell me.
Do AB. Do the AB, that's BC, the bottom, and the AC.
So I have the length of AB, then what?
BC
Plus the length of
BC
BC
equals AC.
is equal to the length of
AC.
AC. So on your papers, I want you to try this. If the length of EG is equal to 59, what are EF and FG? What's the length of EF and FG? You can't see it. EF says 8x minus 14 over it, and then FG says 4x plus 1. Try that on your paper right now.
Done.
Let's go. Guys, you have to write something down. Come on. You got it. How do you think we're going to solve this? Yeah, you can take another minute. Brian, did you have your hand up?
Yeah, I
How-
got 3 seconds.
You got what?
3.
You got 3, 4. What's this question asking?
Oh. Oh, never mind.
Christian, how do you think you're going to solve this?
I just put 8x minus 14 plus 4x plus 1 equals 59.
Why are you able to do that? Justify why you're able to do that.
Because EF plus FG equals EG.
Good. So what is that called? What proof do we have that that is actually correct? What postulate are we using to support that?
1/6
Which is the
segment addition.
postulate. Good. So that is something you guys have to know and be able to justify. You can't just say that, oh, 8x minus 14 plus 4x plus 1 equals 59. How do you know that? You have to do, everything you do has to be backed up by justification in geometry. So this is how, so it's algebra. You guys all know how to solve one-step equations. So, like Christian said, he did the length of EF plus the length of FG equals the length of EG. That's the segment addition postulate. So off to the side, when you guys are doing these problems, you need to tell me what postulate you are using to prove your thinking. You have to justify what you're doing. So then we're substituting, and then we're just solving, combine like terms, bring over the numbers, and then solve for your x. X is equal to 6. And then we're going to substitute that 6 back in. We're going to get 34 and 25. And added together, those are 59. So we are combining your guys' favorite algebra with geometry.
Favorite.
Your favorite. So you have to be able to justify it with a possibility. So try this one. Try this one. I am giving you that the length of JL, so JL is back here, this line segment. JL is going to be 120. And then we are trying to find out what the length of JK is and what the length of KL is. So using justification, tell me how you're going to do that. What do you have to do with that? Yay, nay? Nay? 11, 17, 11. What's 15 plus 6? That's not 9. What's wrong? Yes, what? Okay, then what do you, oh. Alright, let's look at this. So, first of all, what postulate do you use to justify what you're going to do? Yeah, segment addition postulate. Okay, so you're adding those segments together, right? Segment addition, you're adding the segments together to get that big, the length of the long segment. So it's just algebra, set up and equations. Alright, who feels confident enough to come up here and show this class how you did this?
I do. I feel good.
I feel like Lexi is very confident. Alright, well, Brian, you can do that. Alright, remember, Lexi, you have to justify what you're doing. Alright, walk us through it, Lexi. Tell us. She's thinking, she's writing right now. Alright, tell us how you set that up, /y.
I just added these two together because in postulate 1-6, if you add JK and KL, it equals JL.
Good. So she's using the segment addition postulate as her justification. And then you combine like terms. Take that 21 over to the other side. And what did you get for x? 9. Are you finished? Once you get your x value, are you finished? No. We have to plug it in. To find what? What are we finding when we plug it in?
That length, JK and KL.
Good, we're finding the length of JK and KL.
Oh.
If it was just one step, Macy, it wouldn't be hard enough. Alright, so Lexi said our length of JK is 42 and our length of KL is 78. Is everybody agreed? Yes? Alright, moving on. Is everybody comfortable with postulate 1-6?
All you're doing is plugging 9 into both.
To get your length, yes. But you have to justify. Alright, next. That diagram, that picture that was up there, is a prism. What do we know about prisms? They're three-dimensional. What about the line segments? What about the size of prisms?
They're all the same length.
That's a cube.
They have
But
an
there
opposite
are-
side. They have an opposite
Like
side.
the ones that are on the same side of the shape are the same.
Yeah. So like the opposite line segments are going to be equal. The lengths are going to be equal, correct? Alright. So if we just said RJL is equal to 120, what is my length of AC? My line segment AC, what is the length? This is AC if you guys can't see it. Right here. 120. Why? How can you prove that? Good. So what can we say that line segment is? What does it say down here? Congruent. So when two or more line segments have the same length, the line segments are congruent. We will get into this right now. So this is like specific notation that you should know. And different language that you're gonna have to use. You're gonna use the word equals when you're talking about length. So something with like a numerical value. So for example, this line segment AB and the line segment CD, they both have an equal length of 1 inch. So they are congruent. What's congruent, the length or the actual line segment?
The actual one.
The actual line segment. So we are going to use the word congruent for actual line segments. So like line segment AB is congruent to line segment CD. And have you seen how you notate that, like the dashes and then angles? There are the curves that connect, right? Yes.
If, say they're both like the same, the actual line itself is the same length, but like there's different cutoffs. Like there's a cutoff here and a cutoff here. Like there was in the last, or the last problem was 42 and it was like 78. Say they have different cutoffs, are they still congruent?
Did those have different?
But they have the same amounts. Like there's two lines. Right.
No, you're fine.
Like there, there's
Like
two.
here.
There's 3 points. And that equals 120. Say there was another line, and that equals 120. Would they still be concurrent even though there's different points on the line?
Yes. If the line segments are, if they have the same length, they're going to be called congruent. It doesn't matter where the points fall, as long as the overall one has the same length. So, how can you prove congruency? Since we are justifying, how do you prove congruency? Ryan, come on. How do we prove congruency?
Lines are the same. With
Length. If they have equal length or equal distance, they're going to be congruent. So if you have to justify that, that is your justification. Equal distances prove congruency. Alright. Next, what should we call a point that is collinear? What does collinear mean? On the same line. That is directly between two other points. Draw it. What do you guys think that's called? You have a line, the points are collinear, you have 2 points. So you say you have point A and you have point C. I want to put point B right in the middle of those two. Draw it and tell me what you think that's called. So it's going to divide my line segment up into 2 equal lengths on opposite sides.